Good morning, all of you. I am Nalinda Vijayakon, a bilingual science teacher of Dharamapala College, Bandarwala, a provincial teacher trainer, as well as I contributed myself as the national level resource person of National Institute of Education. We know that we all are isolated at homes for about 2 months because of this corona situation. I hope you all are safe. Today, I decided to teach you a science lesson of grade 11 science syllabus. Today, I am going to teach you Unit 7 of grade 11 science syllabus, which is acid, bases and salts. Right. What are acids? What are bases? What are salts? I hope that you all can remind the things that you have learned when you were in grade 7. In our day-to-day life, we use various types of components. For example, in domestic purposes, we use soap, salt, lime juice, vinegar, tamarind, like this. So you can remember all these components that we used in our day-to-day life can be classified into 3 categories as acids, bases and salts. And also, there is another component. What are they? They are indicators. What are called indicators? Indicators means the substances that we use to identify acids, bases and salts. So, can you tell me some examples for acids? Or what are acids? Normally, when we were in the grade 7, we studied that acids are the substances which gives a sour taste. For example, lime juice, lemon, those are the substances which gives a sour taste. But we can't taste all those acids. There are some poisonous or harmful acids in our laboratory. You can remember some of them. Hydrochloric acid, sulfuric acid, nitric acid, those are some examples. Right, first of all, I would like to show you some of the acids, some of the bases and some of the salts that we use commonly in our domestic activities.
And salts: lime juice, vinegar, vitamin C tablets and tamarind are classified as acids, and milk of magnesia, toothpaste. Lime and soap are classified as basic substances, and salt, saline solution, and G-Winnie solution are classified as salts. In this lesson, we will further study about acids, bases, salts. You already know that lime juice, vinegar, vitamin C tablet and tamarind were classified as acids. Lime juice contains citric acid. Vinegar contains acetic acid. Vitamin C contains ascorbic acid. Tamarind contains tartaric acid. Various acids are used in laboratory experiments. For example, sulfuric acid, hydrochloric acid, nitric acid, phosphoric acid, etc. can be stated. When considered the chemical formula of these acids, all these acids contain hydrogen as a component. To study further, click the blinking button on the right. You know that milk of magnesia, toothpaste, lime and soap were classified as basic compounds. Most of the bases are solid compounds. Ammonia is a gas which shows basic properties. Aqueous solutions, prepared by dissolving bases in water, are used for laboratory experiments. Sodium hydroxide, potassium hydroxide, and ammonia solution or ammonium hydroxide are the most widely used bases in laboratory. You may remember that salt, G-Winnie solution, and saline solution were classified as salts. The G-Winnie solution given during ailing conditions, such as diarrhea, and the saline solution given to patients are mixtures containing salts. Bases react with acids to form salts and water. As examples, potassium hydroxide reacts with hydrochloric acid, forming potassium chloride salt and water. Sodium hydroxide reacts with sulfuric acid, forming sodium sulfate salt and water. Magnesium hydroxide reacts with nitric acid, forming magnesium nitrate salt, and water can be stated. Depending on the strength of the reacting acid or the base, the salt shows acidic, basic or neutral properties. For example, the salts formed by the reaction between a strong acid and a strong base show neutral properties. Sodium hydroxide is a strong base. Hydrochloric acid is a strong acid. Sodium chloride formed by the reaction between them is a neutral salt. Similarly, the salts formed by the reaction between a strong acid and a weak base show acidic properties. Ammonium sulfate formed by the reaction between sulfuric acid and ammonium hydroxide is an acidic salt. The salts formed by the reaction between a weak acid and a strong base show basic properties. Sodium acetate, formed by the reaction between acetic acid and sodium hydroxide, is a basic salt. To study further, click the blinking G1E solution and saline solution were classified as properties of salts. Salts are crystalline, solid compounds. Most of the salts dissolve in water. Generally, salts have high melting points and boiling points. To study further, click the blinking.
Dear children, you have observed some of the examples for acids, bases and salts that we use in our day-to-day life. As I explained you earlier, as you learned in previous grades, you all have learned that acids gives a sour taste. But as a grade 11 student, we have to study that how to define acids. What are acids? Do you know? Acids are the substances which release H+ ions in an aqueous medium. As you know that all acids consist of hydrogen atoms. In the aqueous medium, all these hydrogen atoms releases as H+ ions. And also, I'm going to explain you these acids can be classified into two categories as complete acids and incomplete acids. What's the difference between these two? Do you know? Acids that release H+ ions by complete ionization are called as strong acids, while acids which release H+ ions by incomplete ionization are called as weak acids. Now, I'm going to show you how the ionization takes place. Dear children, as I explained you, acids can be classified into two categories as strong acids and weak acids. As you know, there are some examples for strong acids. Hydrochloric acid, H2SO4, sulfuric acid, HNO3 of nitric acid. And also there are some examples for weak acids. Acetic acid, carbonic acid, phosphoric acid. So, as I explained you earlier, how can we classify these acids as strong acids and weak acids? You know, what are acids? Acids are the substances which release H+ ions in an aqueous medium, But here, strong acids are produced by the complete ionization of aqueous solution, ionization of components in an aqueous solution. Weak acids are the acids that produce H plus ions in incomplete ionization. Let's learn how ionization takes place. Strong acids H2SO4 sulfuric acid, how ionization takes place. In an aqueous medium, we represent AQ to indicate that is an aqueous medium. In an aqueous medium, sulfuric acid ionizes as 2 H plus ions aqueous plus sulfate 2 minus and aqueous. So here all the molecules completely dissociate into H plus ions and sulfate ions. These are positive ions, these are negative ions. Let's learn another example, hydrochloric acid. In an aqueous medium, hydrochloric acid ionizes as H plus aqueous plus chloride aqueous. If we consider about nitric acid HNO3, it ionizes as H plus and nitrate ion NO3. About weak acids, as you learned earlier, carbonic acid, acetic acid and phosphoric acid are examples for weak acids. You know that what are weak acids? How do we define the term weak acids? Acids that are incompletely ionizers in an aqueous medium are called as weak acids. What is meant by incomplete ionization? That means in aqueous medium only a fraction of acids ionizers and ionizers into H plus ions as well as the relevant negative ions, and unionized acid molecules remain in the solution in the form of acids. And also we can classify these acids into two categories as concentrated acids and dilute acids. That depends on the amount of water content present in the acids. So you know that in laboratories we store acids. In the laboratory we store these acids as concentrated acids as well as dilute acids. Acids can be diluted by adding water to the particular acid. Here we have to add acid to water, not the water to the acid, because if water is added to the acid, there will be thermal explosions. So it is essential to add acid to the water. Right. Now let's learn about the properties of acids. You know, acids have several properties. What are the common properties? You can remember, you can just refer to the textbook and find out what are the properties of acids. You know, normally we can say that acids have a sour taste. And also the strong acids, for example, sulfuric acid, nitric acid, and hydrochloric acid, if they fall onto the skin, there will be irritations. It is very important to use these acids very carefully. Right. Daruni, we should have a good awareness about the properties of acids. You know, as I explained to you earlier, acids have corrosive properties. That means if acids fall onto our skin or any other surface, there may be damages or irritations or burning sensation can experience that. That is why we call that acids have corrosive properties. And also we know that acids have a sour taste, but it is very important to consider that we should not taste all acids, because some of the weak acids such as citric acid, acetic acid, we can taste, but dangerous acids, harmful acids such as hydrochloric acid, sulfuric acid, and the nitric acid in the laboratory, if we taste, what will happen? There will be a lot of harmful effects. And also another property, all acids react with the metals such as sodium, magnesium, calcium, and produce their salt and hydrogen gas. Here, if the magnesium reacts with the hydrochloric acid, it produces magnesium chloride salt as well as hydrogen gas. And all acids react with carbonates, producing their chloride or the salt, water molecule, and evolves carbon dioxide gas. For example, hydrochloric acid reacts with calcium carbonate to produce calcium chloride salt, a water molecule, and evolves carbon dioxide gas. And although we didn't study about bases, next lesson we are going to study about bases. A sodium hydroxide is a base. Acids react with bases forming their salt and a water molecule. Here, hydrochloric acid reacts with sodium hydroxide, producing the salt, sodium chloride, we call common salt, by producing a water molecule. And also, we have learned when we were in the grade 7, acids have the ability to change the colors of some indicators such as litmus. There are two types of litmus papers, blue litmus, red litmus, and also some other indicators called pH papers. You will learn more information about indicators in next lessons. Right, so now we have to study about the uses of acids. Do you know, normally in day-to-day life we use lime juice, vinegar, there are many uses for cooking purposes, as a germ killer we use acids. But we know that there are many uses of strong acids and other weak acids that we use in laboratories. What are the uses? I'll tell you some of the examples, and for more information you can refer the page number 193 in your grade 11 textbook. For example, the sulfuric acid is used as the battery acid. In vehicle batteries, in the lead acid accumulators, we use sulfuric acids. And also we use hydrochloric acid for removal of rust in steel objects. And there are many uses. And when you think about, the vinegar is the diluted acetic acid. That's all. So more information. Right, now we are going to study about bases. What are bases? How can you define the term bases? You know that in the previous lesson we learned some examples for bases that we use in our day-to-day activities. For example, quicklime, kitchen ash, those are some examples for bases. In the laboratory also we use some bases such as sodium hydroxide, potassium hydroxide, magnesium hydroxide. But we should have a knowledge how to define the term bases. So what are acids? Acids are the substances that release H plus ions in an aqueous medium. Similarly, we can understand that bases are the substances that increase the hydroxyl ion concentration of an aqueous solution. That means sodium hydroxide dissolved in water, it releases hydroxyl ions. Bases also can be categorized into two types as strong bases and weak bases. What are strong bases? Strong bases are the substances that release OH ions or hydroxyl ions by complete ionization. Weak bases are the bases that release OH or hydroxyl ions by incomplete or partial ionization. Right. I'll show you some examples for strong bases and how they ionizes in an aqueous medium. Sodium hydroxide, aqueous medium, dissociate into sodium plus ion aqueous plus hydroxyl ion aqueous. Here, all the molecules in solution ionizes into sodium plus and hydroxyl negative ions. Let's take another example, potassium hydroxide, aqueous medium. Potassium hydroxide ionizes into, dissociate into K plus and hydroxide ions aqueous medium. So these are some of the examples for strong acids. Let's take some examples for weak bases. Here those are strong bases. Weak bases we can take ammonium hydroxide, NH4OH. Here this does not completely ionizes or completely dissociate into ions. Here what happens really is only a fraction of the base molecules ionizes into positive ions as well as the relevant negative hydroxyl ions. The unionized base molecules are remained in the solution. Right, then we can draw attention to the properties of bases. You know, bases have a slimy texture. For example, when you touch a soap, you experience the slimy nature. But we should not touch all the bases because some of the bases are harmful. Next one, all the bases react with acids. For example, sodium hydroxide reacts with sulfuric acid to produce their salt and water. Here, sodium sulfate and water molecule. And also, as we learned earlier, just like the acids, bases also change the color of some of the indicators. For example, they chose blue color with red litmus, likewise. Right, now we have to understand about the uses of bases. So you know that we have to use bases in our day-to-day activities as well as some of the laboratory experiments. There are several uses of bases. For example, you know that bases such as sodium hydroxide are used for the production of soap, papers and artificial silk paints like this. And also you know the magnesium hydroxide. You know, it is a base. Normally the magnesium hydroxide is used as an antacid for the patients with gastritis because you know it is common disease among society, gastritis. So we usually take a tablet called dilution. The dilution tablet consists of a base called magnesium hydroxide. It is called as antacid. And there are some of the other uses of the bases. You can refer to the page number 195 in your grade 11 science textbook. Right. We learn about acids, bases, and salts. Now let's learn about indicators. What are called as indicators? Do you know? You have learned when you were in grade 7. Indicators are the substances used to identify acids, bases, and salts. Do you know we use various types of indicators in our laboratory? For example, litmus papers, phenolphthalein, methyl orange, pH papers are some of the common examples for indicators that we use in our laboratories. So we should understand about how color changes in acidic medium and basic medium with these indicators. Do you know litmus papers? There are two types of litmus papers as red litmus and blue litmus. If we use red litmus, it gives red color in the acidic medium. But if we use blue litmus, it also turns into red color in an acidic medium. Similarly, blue litmus is always blue in the basic medium, but if you use red litmus, it turns blue in the basic medium. So you know phenolphthalein is another indicator. Phenolphthalein gives colorless in acidic medium, while it turns into pink color in basic medium. Similarly, methyl orange gives red color in an acidic medium and yellow color in basic medium. Other than this, we can use pH papers. As you know, pH papers consist of pH papers are usually pale in color, but there is a pH color code. pH color code gives 1 to 14 colors. pH 7 is considered as neutral. 1 to 7 it is for acids and 7 to 14 for bases. Normally, the colors for acid 1 to 7 have a red color range and 7 to 14 have a range of blue colors. That's all. Right, do you know that as we learned earlier, salts are produced by the reaction between acid and a base. You know, for example, we can take sodium hydroxide reacts with hydrochloric acid forming sodium chloride and water. Here, all this aqueous medium, here liquid medium. Here, sodium chloride is a salt. Why? What are called salts? Salts are produced by the neutralization reaction or neutralization of an acid and a base. You know that salts do not show any color with the indicators. We have to understand about some of the salts that we use commonly in our day-to-day life. Sodium chloride, it's a common salt. Sodium chloride, we call common salt, and calcium carbonate, it is salt. Sodium bicarbonate, it is also a salt. Those are some of the example salts that we use in our day-to-day life. Right, so there are many uses of salts. We use sodium chloride for cooking purposes, to giving a taste for the cooking purposes, and also calcium carbonate is used for lime industry, and sodium bicarbonate is also used in the bakery industry. Like there are many uses of salts. You can refer to the textbook to understand about the uses of the salt. Let's talk about neutralization. What is neutralization? As we learned earlier, acid and a base react together to form a salt and water molecule. What happens during this reaction? Really, this is a neutralizing reaction. So what happens to the reaction is here H plus ion released by the acid combined with the negative hydroxyl ions released by the base. These two react together to form a water molecule. This is called as the neutralization reaction. The neutralization means the combination of H plus ion with OH negative ion to form water molecule. You know, there are many uses of acid-base neutralization reactions. We have used them in our day-to-day life for the practical purposes. For example, as I mentioned to you earlier, you know that the patients having the gastritis disease, they take magnesium hydroxide. What happens? No, the gastritis is a disease condition that occurs due to the excess release of hydrochloric acid and burning sensations occurring in the stomach. So, when taking magnesium hydroxide, it is a base, the hydrochloric acid react with the base forming a salt and also a water molecule. Then the patient can experience a relief of pain. And also we use some of the neutralization reactions activities for our agricultural purposes. For example, you know, most of the farmers, they use quicklime, commonly called as quicklime, but the scientific name is calcium oxide. When calcium oxide is added to the cultivation land, it reacts with the rainwater forming calcium hydroxide. Then calcium hydroxide reacts with the acidic nature of the soil and reduces the acidity of the soil. It is very important for the absorption of nutrients for the plants. Likewise, there are many uses of acid-base neutralization reactions. Right, dear children. Now I'm going to summarize the things that we learned today. Today we learn about acids, bases and salts. Examples for acids, examples for bases and salts. Then we learn about their properties and uses. And we learn about how to identify acids, bases and salts using indicators. Now I would like to ask you a question. Do you know how to define acids? Acids are the substances which release H+ ions in an aqueous medium. What are bases? Bases are the substances which increase the hydroxyl ion concentration in an aqueous medium. What are salts? Salts are the substances produced by the neutralization of acids and bases. What are indicators? You can remember. Indicators are the substances used to identify acids, bases and neutrals in the laboratory. Right, now we learn about acids, we learn about bases, we learn about salts, but keep in mind, don't taste all these acids, don't drink these bases, don't touch all the bases because they are harmful to our body. So I hope that you have successfully studied about acids and bases. Acid, bases, salts and indicators. I hope to meet you in next lessons, heat changes associated with chemical reactions. That's all. Thank you.